Welcome back to part two. So we're up until now in this section of notes, we've essentially defined an acid as something that, when it dissociates in water, produces hydrogen ions. And a base is something that, when dissociates in water, produces hydroxide ions. And for the most part, that's correct. But there are some situations where materials that don't have an obvious hydrogen ion or hydroxide ion to give up will act as a base or act as an acid. So another model for acids and bases had to be kind of worked on, tinkered. And in the I believe it's 1800s, two scientists, independent of each other, in Europe, I forget which countries, discovered a new definition or a new way to look at acids and bases. And this is what we now know as the Bronsted-Lowry, named after those two independent scientists, theory. They defined an acid as something that, when in solution, donates a hydrogen ion. And something that is a base is something that in solution accepts a hydrogen ion. So still dealing with hydrogens, not so much with hydroxides. And a conjugate base is what's formed. It acts as a base in what we call the reverse reaction. We'll look at both of those conjugate acids and conjugate bases in a couple of examples. Amphiprotic is something that can serve as an acid or a base. And some examples of these: HCl would be an acid, and NH3 or ammonia would be considered a base. Some properties of acids and bases in this first column here. Acids, I highly recommend against tasting anything in lab, but things that you've tasted that are tasting sour tend to be acidic. So things like citrus fruits, vinegar, soda. Sour Patch Kids actually use ascorbic acid, which is vitamin C, to give them their tart flavor. A lot of times they also load up with citric acid. Acids, when they're solid, tend to be a bit waxy. We're never going to deal with any solid acids here. pH is below 7, and blue litmus paper turns red. And when we add these to bases, they essentially form salt, not necessarily sodium chloride. A salt, remember, chemically is defined as a positive ion combining with a negative ion. So calcium oxide or potassium sulfide would be an example of a salt too. Bases, on the other end, tend to be bitter tasting. Again, don't go around tasting bases. Soaps, shampoos, any of those things tend to be bases. So as a kid, if you had a foul mouth, you'd be threatened to wash your mouth out with soap. And that's not to do any harm because it's a base, but it just tastes terrible. So, bases also tend to be slippery. They're slippery because of a reaction with the fats in your skin and the oils in your skin called saponification. If you went to, in middle school, if you went to the Williamsburg trip, they might have showed you old-fashioned soap making. And the way they do that is they would take animal fat, usually lard, and mix that with sodium hydroxide or lye, sometimes also potash. And that would make soap. So if you spill a base on yourself and it feels slippery, it's slippery because you're basically being turned into soap. For anybody that's seen the movie Fight Club, without giving anything away, there's a scene in there where they're making soap from the remains of liposuctions. They're making human soap. Pretty gross. And pHs of bases tend to be between 7 and 14. They do the opposite. They turn red litmus paper blue. And they also neutralize acids to form salt and water. How do we name acids? Well, if there's no oxygens present, so like HCl, we would do hydro in front of it, and then the base of the other element, like HCl chlorine, Cl chlorine would become chloric. Fluorine would become fluoric. So HF would be hydrofluoric acid. If the anion is an 8 or an 8, like nitrate, or hyponitrate, or pernitrate, or perchlorate, we would use these suffixes.
Did I leave a bag in here?
I didn't see any, Declan. Sorry about that. So these blanks, they're just filling in the root of the 8 or the ite or the plain old element. So If it was hydrogen with bromine, HBr, it would be hydrobromic. HNO3, this is nitrate, so this would be nitric acid. If it was HNO4, it would be pernitric acid. If it was HNO2, it would be nitrous acid. So that's a way that we can name these things. I'll accept either one, but maybe on the midterm or the final, there might be questions to name particular acids, and these are the names that we would use. And that's it. So tomorrow in class, we're going to go over some calculations. We're going to go over how to calculate pH and pOH. We're going to look at some examples. Come with any questions you still might have over this. Obviously, the first time reading through this, you might still have some questions, and that's totally fine. So, we'll see you tomorrow.